Hello, my name is Michael Sliwa, and today I'm going to be drawing the following reaction mechanism that is in text up on the screen right now. And that starts here with butan-2-one reacting with methyl lithium. So we're going to go ahead and start by drawing the butan-2-one. So we know that this is going to have a chain of 4 carbons, hence the butan. And we know that but is 4. So we have 1, 2, 3, 4 carbons in our chain. And we're going to have an one at the 2 carbon, and one endings have to do with ketones, which is just going to be this carbonyl group right here. So we have a carbon right here that's not exactly shown, but is at the end of this, I guess this point here, double bonded to an oxygen, and that gives us our butan-2-one. For clarity's sake, I'm going to go ahead and remove the numbering here, and that's just because, honestly, it's not really needed. We've already kind of numbered this thing, and we know what's going on here. So following that, we are reacting it with the methyl lithium, which is going to look a little bit like this, CH3Li. Now something important to note here is the fact that we're going to have a positive charge on our lithium cation here, and a negative charge on our negative anion here, which is going to be methanide. So obviously those are just, not exactly given those names now because we still have this bond in between our CH3 and our Li. Once they break apart in the following step, we will expect to see those names and those charges, and this will kind of help us with actually drawing this mechanism out. So in the next step, it says that a lone pair of electrons on the negatively charged carbon, so this negative charge is actually here on this carbon here, forms a new bond with the carbonyl carbon, and as we said before, the double bonded oxygen to carbon here is our carbonyl, so that's going to come in here. And it says that it's going to push electrons from the pi bond, which, this right here, this double bond, is made up of a pi bond and a sigma bond, and this pi bond is going to be weaker, so it's going to kind of act like a pair of, or like a lone pair of electrons in a sense, and those electrons are going to get pushed onto the oxygen here. I also forgot to mention that this bond is going to break here, and those electrons are going to go onto the lithium. So what we end up getting here is this alkoxide intermediate, as it says in this step right here. This alkoxide intermediate is then reacted with water, so we have to first draw that here, and what that's going to look like is we're going to have the same 4 carbon structure here, along with a methyl group, since that's what we reacted with and formed a new bond between the 2 carbon with, and also, since we broke this pi bond here, we're just going to have a single bond to oxygen. Now, in doing some accounting, we also know that this oxygen is going to have a negative charge, which will make it the alkoxide, as we were talking about earlier. And we know this due to the fact that oxygen wants to have 6 valence electrons, so here we have 2 coming from the double bond, and then 2 lone pairs that are not shown here, so that's 6, and we're happy, there's no plus, no minus at all, so we're nice and happy. And it wants to have 6, it has 6, so we're good, but here, oxygen has 1 electron from the bond, and then 3 lone pairs that are not shown, so that's 7, not happy, and it's negative. So with that out of the way now, we have our intermediate, and now we're going to react that with water, which we can write as H2O, but just for brevity and accounting sake, it's actually a lot easier to draw it like this, HOH with a positive charge on the proton here, and a negative charge on the hydroxide, which is what water can be composed of and is composed of. So then we say that this alkoxide intermediate is then reacted with water, where a lone pair of electrons on the alkoxide oxygen forms a new bond with a proton from water. So here we go, we'll just take 1 lone pair here that we drew earlier and have it go to that positive charge on the proton here. And we're also going to break this bond here, which will go to the oxygen on the hydroxide here, giving it that negative charge when it leaves. And, the bond with oxygen is breaking, leaving a hydroxide. So here we have, these two split and that bond is broken. So then that forms the final product here, which is still going to have, our butane or butane here with 4 carbons in the chain. And then at the 2 carbon, we're going to have the 2-methyl. So we have that. That's the same as right here. And then now, this is going to have an OH because this proton here went and bonded with the oxygen, forming hydroxide, or, in this sense, we actually got an alcohol, which, hence the 2-ol, we have a 2-ol here, an alcohol at the 2 carbon, with also a byproduct of that lithium coming back in and bonding with the hydroxide. So that is our entire reaction mechanism with all the steps shown, and that basically fulfills everything we had to do for this reaction.